Yes, good morning, guys. We are discussing conic curves. The very first curves in our syllabus, engineering curves. There are conic sections and cycloidal curves like that. Na? So we are discussing conic curves. And the other day we have discussed a general method, which is also called eccentricity method, where we used the eccentricity, we discussed the definition of it. And for all different areas, we have constructed ellipse, parabola, and hyperbola by following that general method. But there are also, for each of the conics, there are certain special methods. For example, for ellipse, there are more than 4 methods, but we do have 4 methods in our syllabus. And for parabola, 3 methods are there in our syllabus. And for hyperbola, also 4 or 5 are typical hyperbola we will be drawing, rectangular hyperbola. For all these separately, special methods are there. So for today, let us discuss how to construct the ellipse by those 4 special methods. So namely, arcs of circles method is the first method. Arcs of circles method. It is also called intersecting arcs method. Do remember, very, very important all this. Arcs of circles method. The name itself gives some hint to us how we are going to get that, right? Arcs of circles method. Intersecting arcs method. Second one is oblong method, or we also call rectangle method. Third one is parallelogram method. Fourth one is concentric circles method. So these are the 4 methods. So one by one we'll discuss. Let us go for the very first one. That is arcs of circles method or intersecting arcs method. Right. Okay. So there is a mathematical definition for ellipse. You can define it in any way, but this is one way. I'm just reading it out. It is a locus of a point moving in a plane such that the sum of its distances from 2 fixed points always remains constant. The sum of its distances, sum, S-U-M, sum. There are 2 fixed points. So let us try to understand what exactly is the definition. I read it again. It is a locus of a point moving in a plane such that the sum of its distances from 2 fixed points always remains constant. So let us try to get to what exactly is given in the definition. It is said that there are 2 fixed points. That means there must be a fixed distance between those 2 fixed points, obviously. So that should be given to us. The distance between the 2 fixed points should be given to us in order to follow this definition and get the ellipse constructed, right? And again, the condition, what is the condition? A point is moving in relation to these 2 fixed points. These 2 fixed points, they are called foci, focus 1 and focus 2. So in relation to these foci, a point is moving in such a way that always the sum of its distances from those 2 foci is always constant. It remains constant. So that sum is nothing but the major axis of the ellipse that we are going to get. So this is how we have to satisfy. We have to first locate those 2 points as given by the data. The distance would be given to us. So after locating that, we have to ensure the sum of its distances. But that also will be given the length of the major axis or the sum of because the question may resemble the definition, or the question may straight away the distance between the 2 foci is this much and the major axis length is this much. The question may be given. So you need to have a grip over the definition and its meaning. That is very important, because sometimes the question may be given the way it is given, the question is formatted in different ways. So we have to be very serious in getting to the concept of that, the inner meaning of that, so that whatever maybe the pattern the question is posed to us, we'll easily get the meaning and we'll get to the method that we are going to follow. Next. So let us take up a question. Let us take up a question in order to follow this here. Major axis AB and minor axis CD are 100 millimeters and 70 mm long respectively. Major axis and minor axis are given here. They are 100 mm and 70 mm. And it is said draw ellipse by arcs of circles method. So let us follow here. Step by step here. Here one thing is tricky here because we know as we discussed in order to not this. Oh. Right. So, but in order to follow this arcs of circles method, we actually require two parameters. One is the two fixed points, namely the distance between the foci we require. The second one is the major axis, length of the major axis. These two we require. But here in the problem, here in the data, major axis length is given, but instead of giving the distance between the foci, the data mentions minor axis, length of the minor axis. So it's a little tricky. We need to understand that. So how to get located the foci? How to get the foci located by these given parameters? So first one, draw a horizontal line. Let's say that is equal to the major axis AB, right? And next, so that is AB. The next is minor axis. We know that major axis and minor axis are mutually perpendicular bisectors. Therefore, find the midpoint of AB, let's say O, and through that, write the minor axis perpendicular to it such that on one side, the OC, let's say this is O, then that is OC equal to OD equal to 35, because let us place this A, B, C, D symmetrically about that point O. Next, that is O. So OC equal to OD equal to 35. OA equal to OB equal to 50. Right? Next. So now, how to find this? That is F1. That is F2. That is foci 1, foci 2. How did we get this? This CF1, that means you are going to take a C as center. CF1, that means in order to locate that F1, you need to take certain radius. CF1 is equal to CF2. That is one endpoint of the minor axis to the one of the foci. So it is CF1 is equal to CF2, but this is equal to half of the major axis. That means OA. That is half of the major axis means it is 50. So take 50 mm radius and C as center, draw two arcs to cut AB at F1 and F2. Thereby we are getting the foci located on AB. So now we got the major axis length as it is AB, and we got the F1 and F2 exactly. So that would be, maybe we are not interested in the length, but they are fixed already by particular method. So now, next. Sometimes straight away F1, F2 will be given. So there won't be any problem. All these 3 or 4 steps, we don't need them. So here, let us go for the construction further. Right? So divide, or let's say randomly locate certain points between O and F1. Or let's say between F1 and F2. But it is enough to locate F between O and F1. That means you have to locate points randomly interior to the F1, F2. Within the F1, F2, you have to locate certain points. Randomly, you can go for random, no need of equidistant. Right. Equidistant means it is time consuming. So here I have taken 4 points between O and F1. Right? Now, already we have gotten them, F1, F2, we have to use that condition. We have to use that length of the major axis in order to find various points to connect to get our ellipse. So now, let us take A1 as radius, A1 as radius, F1 as center, A1 as radius, F1 as center, draw an arc. Next, F2 as center, B1 as radius, cut that previous arc. Here you are seeing it A1, take A1 as one radius, B1 as another radius. You are taking F1, F2 as centers to find one point. They are cutting, when you draw arcs, they are cutting, intersecting each other at one point. That means what? A1 plus B1 is equal to AB. That is, the definition is followed. It is being satisfied. Therefore, F1 as center, A1 as radius, draw an arc. F2 as center, B1 as radius, draw another arc to cut the previous one. Right? Next, take A2. Now increase the radius from F1. A2 as radius, draw another arc. B2 as radius, F2 as center, draw the arc to cut the previous arc. So thereby we are getting another point. Likewise, you take the third one, A3 as radius, F1 as center, draw an arc, and then B3 as radius, F2 as center, draw an arc to cut the previous arc to get the third point in the first quarter. As you look at that, it is divided into 4 quarters because the axes are mutually perpendicular bisectors. Therefore, you can easily say that it is divided, the space is divided into 4 equal parts. Let's say the first quarter we are getting, already we got 3 points, another point. Take it successfully, do the same. A4 as radius, F1 as center. B4 as radius, F2 as. That means F1 and F2 are the centers to locate the point, to draw the arc to get the points, right? But slowly you first take A1, B1, A2, B2, A3. Next one is obviously A4, B4. So you got 4 points here. Similarly, you can go for, that is first point, second point, third. Same manner you do in the other quarters. Same tape, same points you can take, same radius you can take. Only thing now you just change the centers. Previously you were taking F1 as center for A1 radius. Now you take F2 as center. Draw that A1 as center, F2 as center. The remaining one is B1. F1 as center, cut the previous arc to get these 4 points. So another 4 points we got in the second quarter, E5, P6, P7, P8. In the same manner, we'll be doing it in the other. All the points to get a beautiful ellipse. Initially with a light line. All the other construction lines, keep them light in order for that ellipse is seen glaringly visible out of the cluster of lines, right? So this is how we go about it. The question may be given directly, that is the distance between the foci and the major axis straight away, which are the required parameters to follow the arcs of circles method. That may be given directly, or it may be given like in the case of this present case. Here it is major axis, minor axis have been given. So first duty is to locate F1 and F2 properly. For that we have followed certain things and steps are here given. So you can follow, you can repeatedly say this. And if you still have any doubts, straight away you can call me or SMS me at any time, right? Okay guys, with this, it is first method is over. Next, okay.